Assalamualaikum. We are from group 12. So today our group gonna present for interim progress presentation. So our group the title for our group project is Whale Drive System for Mars Exploration. So this is our group member Iyai, Farhana, me, and Shamimi and Hadi. So I think I will pass to Mimi to explain about the introduction of our project.
Okay, hi. My name is Shamimi, and I will explain about the introduction for our project. So, uh, our uh, our project is about wheel drive on the Mars. So, first of all, I will introduce to you guys about the Mars. The Mars or the red planet is the fourth planet from the sun, and Mars have two small moons. And as we all know, this planet will be our next planet after the Earth. Okay, next I will explain about the rovers itself. Um, the rovers help human to discover more about Mars. So at Mars, iron oxide chemicals at the Mars surface makes rover difficult to move. So we are giving the task to make the wheel that are very special and complicated design, since there is no mechanics or technician on the Mars. And also the gearing system and the drive shaft also make the rover to climb or move at the Mars surface for the exploration purpose. Okay, that's all.
Okay. So for problem statement, I will present this slide. Okay. So the project title for our group is the specific title is gaining traction on Mars. So the goal of the design for this project is we have to design a wheel drive system for use during human exploration of Mars. So that's the objective that we need to achieve in the end of the our project. So the design that we have to make is at least consists two wheels with associated drive shaft and gearing systems. The performance must take into account a characteristic of Martian surface and limitations of NASA's Mars mission. So that's the problem statement for our project. So after we understand and analyze the project statement of our group, so our group have already done the Gantt chart, the project planning. So this is the Gantt chart. We use Gantt chart for the project planning. So firstly, we have briefing and do some research, progress stage 1, progress stage 2, progress stage 3. So the right side of the Gantt chart is the due for each task. And each task we have already distribute for each member. So I think that's all. I will pass to Yet to explain about design requirement.
Okay, thank you, Juliana. For the design, I'm going to present the design requirement. So for the design requirement, we need to make sure that the design is suitable for human exploration on Mars, because as we know, we designing the exploration Mars rover. So we need to take the surface and the surface of the Mars and the surrounding into consideration of our design. Thus, to cope with all those circumstances, there are several design requirements that need to be developed. Now, the first is the wheel drive system that consists of at least two wheels. It has a four-wheel drive system which has both front and rear wheels on the vehicle, and it allows to spin simultaneously. And it has two drive shafts which are connected to the rear differential and also front differential. And second one is the type of wheels. It built with material that is strong and lightweight, and the wheel surface is flexible and has grouses attached. As for the wheel rims, materials used are type of steels so that it has enough strength to connect with the drive shaft. And for the chassis, it has to be lightweight, which is 5% lighter than the reference rover to apply minimal ground pressure on weak soils so it can avoid sinkage. Next, for the body, the length is 2.5 to 3 meters approximately. The width is 2.5 to 3 meters approximately. The height is 1.5 to 2.5 meters approximately. And it's so lightweight, which is 5% lower than existing product. And for the suspension, it need to allow the stability for the rover to move through the uneven surface of the mast, and also need to absorb a large percentage of impact the rover will experience when landing. As for gearing system, we use a differential gearing system that actually create a three-link differential motion that allows the left side of suspension to go up when the right side suspension to goes down. The three-link actually connected to the wheels, and to the engine. So I think I will pass to Fana for the conceptual design.
Okay, thank you Iyad for the explanation. So I will continue further about the conceptual design. Okay, so for first design, in Lala, we have torque sensor. The wheel torque sensor is currently located in the central part of the wheel and the lower part of the wheel fork. Okay, the next, the wheel is flexible because it has a spring inside it. The drive motor is located in the center of the wheel and provides the turning force to spin the wheel. For the suspension, this design using rocker body suspension, which enable the rover to drive through the rocky terrain. And the chassis is heavy and not flexible, and it's hard to design, which is too complex. Okay, so second design is LIPA. In this design, it also using rocker body suspension mechanism. It has 6-wheel drive. The body and tires were also made of materials that light in weight. The design of chassis and wheels are not complex and easily to board. The chassis and wheels are made of strong materials that can withstand the environment on the Mars planet. Okay. Next design is next slide. Okay. Thank you. Okay, so for the third design is Lilo. It has 6-wheel drive. The drive system is in the drive system it has high torque heavy duty motors, which does not okay. For the motors, it doesn't require in the design requirement as the drive system using as in design requirement using the drive system which is drive shaft instead of motors. Using rocker boogie mechanism, which the wheels can move up to 360 degrees. The suspension system has springs so that the rover can move into any type of muddy and sandy surface to keep its balance, and has simple chassis body which easily to move and lightweight. Okay, so for LOFA, it has 8-wheel drive mechanism. It using motors in the wheel drive system. Also, it has spider legs, which ensure that it can traverse over a considerable height greater than the chassis height. The chassis has many shafts attached, which is difficult to build. So we observe that the mechanism of all design we discussed it doesn't include drive shaft in the wheel drive system. This we will improvise this design based on the design requirement that Iyad mentioned just now. Okay, thank you.
Okay, thank you. So for the
Okay,
design
I will
selection
pass to
method.
Okay.
Okay, so for the design selection method, actually we already choose the best design. So we are comparing our design with the reference design. So here are the criteria that we are looking for, which is number one is wheel drive system. So we are looking for the drive shaft and gearing system on on our design. And the second criteria is durability. So because of lack of spare parts on Mars, we're looking for the design that are able to withstand all conditions on Mars planet, and in other words, are long lasting. Okay, so for the third criteria, which is stability, so we are looking for suspension actually, because when driving over uneven terrain, suspension system maintains constant weight on each rover's wheel. So suspension minimize rover tilt as it drives, keeping it more stable. Okay, criteria number 4, which is flexibility. So we are looking for the design that are able to overcome any obstacle on surface, example, terrain, hard surface, and uneven surface. And criteria number 5, which is lightweight. So we are looking for the chassis that are lightweight because you need to apply minimal ground pressure to float on weak soil. And the last criteria is easy to build. So we are looking for the design that are not too complex and possible to build. Okay, so I think we are already, I think that's all for our interim video. So thank you.
Thank you.